Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I kind of like to request our members to subscribe, engage us in the comment section, and also ring that notification bell so that we can be getting updates on various uploads we're going to do in similar topic. Now, in this case, I would also like to request us to check our description boxes for various links, and we're going to also upload other similar video or the links to other similar videos, of course, with the same topics under discussion as I've said. Now in this case, I'm going to look at the special properties of the arithmetic mean. And from our last discussion, basically, we had defined the arithmetic mean as the sum of the magnitude of items divided by the number of items. And we had used two specific representations for giving this particular mean using this specific notation. Now in this case, I have said that we can give the abbreviation for the arithmetic mean in terms of these three specific notations: A, M, or X bar given as such. Now for ungroup data, we have said that we're going to represent the arithmetic mean by giving it as a summation from the first set of observation to the last one of specific items of a variable of X, given as the ratio between the summation and the, of course, the number of items given as such. And of course, we used a second specific definition for a group kind of data in terms of the summation between the first items and the last class. And of course, this constituted the concept of a frequency, and therefore we give that one as a ratio between that one and the total number of frequency given as such. Now, we have decided, of course, that we're going to consider various range of cases for especially the classes, which constitute data which has been grouped into a specific number of classes for the sake of convenience. Now, in this case, we're going to look at specific properties of the arithmetic mean, and these are going to assist us in trying to evaluate various aspects of the arithmetic mean in case we come across them in our various discussion. Now, in this case, the first property that we're going to look at is going to, of course, be constituting what we refer to as deviations. And these are going to be the specific difference between a particular variable and the mean, as we're going to see. Now, the sum of the deviations of a set of specific items of the mean are going to be 0. And of course, this is going to be given in terms of the summation of a specific set of items, as I said, which is the sum of the deviations of a specific set of items from the mean. These are going to be equivalent to 0 given as such. And that is going to be one of the properties of the arithmetic mean, as we are going to see. And of course, we are going to consider this specific set of, I've mentioned about the deviation from the mean. And in some cases, we're going to consider a general case whereby we're going to see that we can have a case whereby we're going to consider this division of items from the mean and an arbitrary value, and try to see what are some of the implications of this. So suppose we have the summation of the square of deviations of these specific values from the mean. We're going to see that this is going to be a value that is always smaller than the summation of items of a particular value, or of the deviations of an arbitrary value from the this set of course, xi given as such. So if we're going to have an arbitrary value which is going to be given as, of course, which is not equivalent to the mean, we're going to see that if we try to compare the deviation from the mean of this specific set of values from the x variable, are going to be always smaller than the square of the deviations of items from a particular arbitrary value of a given as such. And that's going to be constituting one of the properties of the mean. But of course, we're going to see that this specific arbitrary value a, is not equivalent to the mean, as we say. And this is going to be a second property of the arithmetic mean. Now, in this case, we can also consider a specific set of frequencies, as we said, which are going to be representing the various means. So suppose we have a specific distribution of data, which is going to give us a mean of x bar 1, and perhaps this mean is going to occur in a number of frequency given, or it's going to occur in a number of observations given as n1. And therefore, if we have a second set of items with a mean x2, which are going to occur in a n2 set of observations, we can, of course, look at this specific representation of a mean, so a particular set of classes given as k, and of course, these are going to occur, of course, in n k times of that specific observation. And of course, we're going to see that the above set of data for the option for this specific case for number 3 is going to be represented using a collective mean. And this, of course, collective mean is going to be referred to as the combined mean. Now, this specific combined mean is going to be given as, of course, the summation of the product of this specific mean and the number of observations, and of course divided by the total number of observations given by this specific set of all the observations occurring as such. Now perhaps we can represent that one in a algebraic representation, which is going to give us a clue on what basically this combined mean is. So I've said that in case we have a set of items which have got a mean of x1 and occurring n1 times, this is going to go in this specific series, of course, and this, of course, we can find the general mean of these specific means and the total observations by referring to it as a combined mean, and this is going to constitute the summation of the various means and their respective observations going in this specific order, and this is going to go on to a number of course, x k and nk given as such, and that is going to be divided by the number of observations, the sum of the number of observations given as such, going on to nk times given as such. So this kind of a mean is referred to as the combined mean, and that's going to be one of the properties of the arithmetic mean that we're going to see being displayed. Now perhaps we can use this as particular specific simple example in trying to evaluate a specific combined mean, and that's going to assist us in trying to comprehend basically what this specific third property entails. Suppose in a particular stream class consists of female and male students, and these are going to be given in terms of numbers. Of course, these female students are 30 in number and the male students are 70. And this, of course, information is going to be giving us the direct number of observations for this respective set of male and female. And therefore, we're going to have our N1 represented as 30 and N2 for the number of males representing 70 in that particular case. And if these specific students are going to perform a test, and their specific scores are going to give averages for the females. 30 females are going to have an average of 60, and the 70 males are going to have an average of 72 in that specific test. Therefore, we're going to consider these two specific set of data for the two averages and the two number of observations for 30 and 70 in trying to compute what we refer to as the combined, sorry for that, the combined mean. And in this case, we are going to use our general formula in this particular case. Now we can reduce this specific formula by giving it as the summation over x I, and then we're going to have it given as, so in this case, we're going to consider that specific set of data where we're going to have the first mean and the first observation, which is n1, plus the second mean and the second observation, which is the total number of the other students, and then we're going to have this one divided by the sum of n1 plus n2 given as such. So this is going to give us a combined mean, and of course we're going to see that from this particular case we're going to have a general representation of the summation from I is equivalent to 1 to 2. So we're going to have these two sets of specific values for n, and then we shall have xi, ni given as such, divided by the summation from I is equivalent to 1 to 2 over this specific ni for a general case. So in this case, if we try to look at that, then therefore we can do a direct substitution in this particular case for representing our combined mean. So we are going to have our x1 represented as 60, and therefore this is going to be 60 and have it as a product with n1. n1 is equivalent to 30, and we're going to have that one as a sum with the second one, which is going to be 72 times 70, and that's going to constitute x2 and n2, and that one divided by the total number of students, which is n1 plus n2, and this is going to give us a total of 100. So that's going to give us the total of 68.40, and this is going to be our combined mean for the total class that constitute of the male and the female students given as such. So in this case, this is how we're going to evaluate the concept of this particular third property of the arithmetic mean, in case we come across a specific set of means, and of course the various types of observations for these respective means in that particular order. So I hope we have understood. Kindly check our description boxes for various links of other similar videos which we're going to do under the concept of averages. So that is it for now, guys. Bye, God bless you. Catch us in our next video.